Hello, this mini lecture is on domain and range part 1. So first we need to understand what is domain. Domain is all possible independent, usually x values. Range is all possible dependent, which is usually y values. So in this set of points that you see on the screen here, that came from an unknown relation. We don't even need to know the graph of it. We need to state the domain. The domain as a set would be all possible x values. So the x values are simply 6, 4, -5, and -1. The range is all possible y values, or 8, 0, 3, and -2. Domain is all x values, range is all y values. However, there's a little more difficult problems when you come to equations. So suppose that we had y is equal to the square root of 3x plus 5. If you have the square root of a negative, you have imaginary, not real. So what do we need to do? If we are graphing in the real number system, we need to set 3x plus 5 greater than or equal to 0. Why? Because we don't want negatives. So subtracting 5 and dividing by 3, you can see that x must be greater than or equal to -5/3. So as an interval, that would be bracket -5/3, comma, infinity. Meaning that anything greater than or equal to -5/3 is in the domain of this function. As far as range goes, you would need to graph this. Many times we're not as concerned with the range, it's a byproduct of the domain. So we are going to stick with identifying the domain of this. What about y is equal to the square root of -7x plus 1? Same procedure. Set greater than or equal to 0 and solve. Now when you divide by -7 here, you should recall to flip the inequality. So this goes from -infinity to 1/7. And you want to include 1/7. So this is domain of a square root function. What about if we had another equation? This time it was a fraction. So 4 over x minus 1. You'll recall that you cannot divide by 0. So what would cause the denominator to have a 0? Well, set x minus 1 equals 0, solve. So we're going to say that x cannot be 1, or the denominator will be equaling 0. Everything else will work. So just remember that we are looking at the denominator only. The numerator can be 0, so x could be 5, but the denominator cannot be 0. So therefore, in this one here, x cannot be equal to -2. Well, not everything is as easy as that. You might need to do some factoring. So let's have y equals x plus 4 over 6x squared plus 13x minus 5. Let's factor this. That way we know what the denominator cannot be. If you factor this, you get 2x plus 5 and 3x minus 1. You do not want the denominator to be 0. So therefore, 2x plus 5, set that equal 0 and solve. X, if it's negative 5 halves, will result in 0 in the denominator. So therefore, x cannot be negative 5 halves. Same thing with 3x minus 1. Set that equals 0. Solve. Same thing. Therefore, x cannot be 1/3. As a summary, the domain is the x values, the range is the y values, for square roots, you do not want the square root of a negative. And rational functions, those are the fractions. You do not want 0 in the denominator. Now, one quick note on the square roots, not wanting a square root of a negative is what we're aiming for. X itself can be negative, but when computed, the square root cannot have a negative underneath it.